Nolan é Program Manager para o Microsoft Edge. Ele contribuiu para diversos projetos JavaScript open source e tem sido conhecido por escrever bastante sobre Promises, JavaScript Publishing e Pokémon. Ele é apaixonado por performance web e offline first. Na sua palestra, ele falará sobre Web Workers e Service Workers, dois novos recursos interessantes para a web, paralelismo e offline.
Hello! Oh, I'm so loud. I'm sorry. Okay. Someone turn my mic down. I'm a very loud speaker, so you may want to turn that down just a tad bit. I'm supposed to let you all know that you should be tweeting right now with the hashtag BrazilJS. So hashtag BrazilJS. We're actually trending right now on Twitter. We're number 5, right behind Renan Calheiros, the president of the Brazilian Senate. So yeah, he's at number 4, we're at number 5. Obviously, we want to beat him because clearly we're more important than the Brazilian Senate, right? So please get your hashtags out. Go hashtag BrazilJS. So thank you for the introduction. My name is Nolan Lawson, and this talk is called We Can Work It Out. It's all about web workers and service workers. So let's just dive right in. So if you've been following the hubbub on the internet over the past year or so, you might have heard some breathless commentary like this from Ponyfu saying, service worker is a revolution of the web platform, right? Revolution. This is very strong language, right? Or you might have also heard Malte Ubel, who is the head of the AMP team at Google. So he says, 2016 will be the year of concurrency on the web thanks to web workers. Right? So these things, service workers, web workers, these are a revolution, right? 2016 is going to be defined by this thing. And if you've been doing JavaScript for a long time, like a very reasonable reaction to reading stuff like this is to say to yourself, okay, is this just another case of everybody aboard the hype train? Right? Like we're used to this with JavaScript. It can get kind of overwhelming sometimes. But what I'd like to do in this talk is I would like to demonstrate to you that web workers and service workers, the hype behind them is actually justified, and that these APIs really do have the potential to fundamentally change the way that we build web applications for the better, to deliver a better user experience to the people using our websites. Okay, so who am I? I'm Nolan Lawson. I look like that, in case you needed to check. I work for Microsoft on the Edge team, who we've just shipped Edge 14. And this is actually not our marketing campaign, but I kind of wish it was, because I'm a child of the 90s, and I love this kind of retro stuff, so I think this is hilarious. But we just shipped Edge 14. We shipped a lot of new goodness in it. It's got fetch, it's got web notifications, it's got beacon API, lots of new ES6 stuff, so definitely go check it out. If you are on Windows, you probably already have it. If you are on a Mac, what you should do is you should go to edge.ms, and you should click up there to where it says virtual machines, and you can just download one. You can test Edge, you can test IE, you can test lots of old versions of IE, actually. Super easy to get up and running. What you should also do is we have a booth back there, and you should go there because we have this thing, this site scanner, that will scan your website and check for modern HTML5 usage, browser interoperability, cross-browser issues. And I kid you not, if you score 100% on this, you will get an Xbox 360 and a Kinect on the spot. Like, apparently the test is really hard to pass. My own website did not pass it. But if you can score 100%, if you're the first person to score 100%, you actually win an Xbox 360. So that is something good to know. Okay, so end of sponsored content. So when we talk about web workers and service workers, I really like to begin talking about web workers because they're the older API, they're the better supported API, and I believe that understanding web workers gives you a good foundation for understanding service workers because the two APIs are very, very similar. They have a lot in common. And to justify why we need web workers, why we need web workers in the web platform, as with any new web platform API that we add, we need to justify it to web developers. Why is this thing needed? Why should you use it in your website? Why should you expend valuable brain energy thinking about yet another web platform API that someone coming up on a stage is telling you is amazing? Well, when I like to explain why we need web workers on the web, I like to use an example like this. So you can try this at home. This is a very simple example to do yourself. All you need is a web page and a regular old animated GIF. Just any old animated GIF. And what I want you to do is I want you to pop open your console, and I want you to do some kind of long-running JavaScript operation. Like here, I'm doing something super dumb. I'm just doing math.random in a loop like a million times. But what you'll notice is this really curious effect where the animated GIF just comes to a complete halt. Just comes to a grinding halt while the JavaScript is running. And this isn't browser specific. You can reproduce this in all the browsers. You can reproduce this in Edge, in Firefox, in Safari, in Chrome. It's exactly the same behavior. And that'd be bad enough if it was just GIFs, right? We love our GIFs, right? We don't want our GIFs to stop, right? But as it turns out, this applies to more than just animated GIFs. This applies to just about anything on your page that moves. So if you've got HTML5 video, or if you've got CSS animations, JavaScript animations, those will all stop while the JavaScript is running. And if you've got form elements in your page, you actually can't even interact with them. Like, watch, I can't click that checkbox while the JavaScript is running. Like, during the execution of this JavaScript, the page just becomes completely non-functional. Not only does it freeze, but I actually can't use it as a user. Now, of course, the reason that this happens, as many of us know, is that JavaScript is single-threaded, right? And the DOM is single-threaded. So when JavaScript is doing something, the DOM can't do anything. And when the DOM is doing stuff, JavaScript can't do anything, right? And I think a lot of us know this, like we kind of realize this as we're writing JavaScript, but we didn't really let the gravity of that statement kind of sink in. Because if you think about that, if you think about what that statement really means, what that means, essentially, is that, this is true, every line of front-end JavaScript that you've ever written has at least momentarily completely stopped your page from working. Right? That's what that means. And when you realize this, it really impresses upon you this huge responsibility that we have when we're using JavaScript on our pages, not to just totally break our sites, because we can do that. We have the power to just break the site with JavaScript. Now, I'm not getting up here to say that we shouldn't use JavaScript on our pages. JavaScript is great. We want interactivity in our pages. JavaScript is amazing. But it's good to know exactly how much JavaScript you can get away with before you start to see these kinds of effects. So, to illustrate this, I like to bring out this example. So, keeping in mind that you're not doing one long JavaScript operation that completely freezes the page, watch this effect right here. So, I want you to watch those animations and watch what happens as I use this page. Now, this page differs from the previous one because what you're seeing here is not that the animations are completely stopped. What you see is they kind of stop and kind of start and kind of stop and kind of start, right? And when I interact with the page, like, it's totally usable. Like, I can click on things, and that's all fine. The page works. But something feels kind of off. Like, when I scroll, the scroll bar gets a little stuck sometimes, right? Who here's seen a page like this? Like, we've all seen pages like this, right? Especially on the mobile web. This kind of page is the scourge of the mobile web. And what's going on here is that this is not one long JavaScript operation that just completely halts the page for, like, milliseconds on end. What's going on here is lots of little JavaScript operations adding up over time, right? So this is death by 1,000 cuts that we're seeing here. And this effect goes by many names. We call it jank, jitter, stutter, but ultimately, this is the cause of that. So the question is exactly how much JavaScript can you get away with before you start to see this janky effect in your pages? And to answer that, we can use a little bit of math. So it turns out that most screens are set to refresh at 60 frames per second, which means that they are flashing 60 images in rapid succession, one after the other, which gives the illusion of motion. Right? It's exactly like this old-timey flipbook. It's the same parlor trick that worked 100 years ago. It just works a lot better now because we're flashing more images faster. And it turns out that 50, 60 frames per second, that's about the limit of what the human eye can detect in terms of something looking smooth versus starting to get this kind of stop-motion, janky appearance. And if you take that number, if you take that 60 frames, you take 1,000 milliseconds in a second, you divide it by 60 frames, you get this number, 16.7 milliseconds. And this is a very famous number, and justifiably so, because what this number tells you is it tells you exactly how much JavaScript you can execute inside of a frame without dropping frames, without starting to dip below 60 frames per second, without starting to get this stop-motion, janky effect. 16.7 milliseconds, that's like nothing, right? That's like the blink of an eye. That's That's like a hundredth of a second. It's tiny, right? And if this feels punishingly small on desktop, it's even more so on mobile, because on mobile we have less powerful CPUs, but we still want to hit that 60 frames per second mark, right? We still want to get everything done within 16.7 milliseconds. And when you factor in the fact that you have like your frameworks that are doing stuff, you have your JavaScript libraries that are doing stuff, and you have the browser that's doing stuff often on the main thread, like this can get really, really small. You can find yourself with 10 milliseconds, 5 milliseconds, practically nothing left over. And when I highlight this problem, this fundamental problem that the web has, the response that I find that I often get from JavaScript developers is, oh, JavaScript has solved this problem. We solved it with asynchronicity, right? Because yes, JavaScript is single-threaded and the DOM is single-threaded, but we solved this because we have all these asynchronous APIs. That's how Ajax works. That's how a lot of the storage APIs work. I mean, this is why Node is so amazing, right? Because Node has non-blocking I/O, right? So it doesn't just solve all of our problems. And the answer is that it does mitigate the problems, but it doesn't completely solve them. And this is a very subtle problem that I find a lot of JavaScript developers aren't aware of. I was not aware of it until recently. And basically, you can state the problem like this, which is the myth that a lot of JavaScript developers like to believe about asynchronicity is that when you invoke a callback or when you invoke a promise or an event listener or any of these asynchronous APIs, what we like to believe is okay, when I call this asynchronous API, like say it's just, this is just jQuery $.getJSON, right? This is just Ajax. We've seen this a million times before. When I invoke this API, everything between this point and the point where I get the callback, that's all free, right? That doesn't block the main thread, except it does if you actually test it. So it's not to say that this completely blocks during the entire execution of the asynchronous API. It doesn't block 100%, but it also doesn't block 0% either. And it varies from browser to browser, and it varies from API to API, but that number is always somewhere between 0 and 100. So certain APIs, it may shock you, really strongly exhibit this behavior. So one of them, for instance, is IndexedDB. So IndexedDB was kind of sold to us as, it's the asynchronous version of local storage, right? So it's more performant than local storage because local storage is synchronous. It blocks the DOM. IndexedDB is all callbacks, right? So it's got to be better for DOM performance, right? Unless you actually test it in browsers. And I did. I wrote this little tool, browser database comparison. And if you test this out, you can easily block the DOM with IndexedDB using this thing. And I'm bringing this GIF to a complete halt, just like I was showing earlier. And this is IndexedDB. This is IndexedDB, which is pure callbacks. There's very little synchronicity in it. But you can still easily block the DOM. Now, this does vary from browser to browser. Certain browsers exhibit this behavior worse than other ones. But this can be very surprising if you think that callbacks are free. Another thing that can block, plain old Ajax. Yes, regular old asynchronous XHR. This is a thing that can actually block. And if you don't believe me, then I encourage you to just try this example with regular old $.Ajax. And all you have to do is just do it enough. And here I'm doing it enough times so that you can really see the slowdown effect on the GIF. But this is just Ajax, right? This is the kind of thing that we tend to think, oh, it's asynchronous, there's a callback, this can't possibly block. But it does. Now, this is kind of a contrived example because I'm doing this many, many times so you can really see the effect. But you'll often see this on a typical web page, especially if you are doing Ajax for a large JSON object. And then when you download that JSON object, you got to do JSON.parse on it, right? That runs on the main thread. Or you see this a lot with image decoding. If you're downloading a lot of images, image decoding happens on the main thread. So these things are not free. And this thinking among web developers that these asynchronous APIs are just completely free, I find it's so ingrained that it's kind of interesting. Like there was a blog post that came out a few months ago talking about the Fetch API, and how it has this API response.json. And what does this do? This gives you a promise for parse JSON, right? And the thrust of the blog post was, oh, this is amazing. Since this is a promise, this is non-blocking, right? So we finally have non-blocking JSON parsing in the browser thanks to Fetch. Oh, this is amazing. Unless you actually test it in browsers, which I did. And it turns out that this actually blocks, this API, which is fully asynchronous, it's just a promise. It actually blocks in all 4 browsers. In fact, it blocks as badly, if not worse, than a regular old JSON.parse. So I tested this in Edge, in Chrome, in Firefox, in Safari, exactly the same effect. So, all right, stuff that can block the DOM that may surprise you actually blocks the DOM that we've covered. So, IndexedDB. Yes, IndexedDB heavily blocks the DOM depending on the browser you're using. Ajax doesn't block the DOM nearly as much as IndexedDB, but it can depending on what you're doing, definitely. Fetch, yes, that response for parse JSON doesn't mean that it runs on a background thread, necessarily. And all this stuff, browser vendors, we're constantly trying to optimize these things. We're constantly trying to move things onto background threads when we can. But even with all of that, all of this JavaScript that you're doing, you are allocating event listeners. You are doing structured cloning. You're doing the kinds of things that invoke garbage collection. And then garbage collection runs on the main thread. And all of these things may seem small, but they are just nicking away at that teensy tiny 16.7 millisecond budget that you have. And every library and third-party script in your page is doing the same. So the point I want to get across to you is just that JavaScript itself just blocks the DOM. And the more JavaScript you are doing inside of your web application, the more likely you are to see this kind of janky effect that I was showing earlier. And when we ship down applications that are like 7, 8 megabytes of JavaScript, and I've seen a lot of web pages that do this, we're not really thinking about the impact that this has on the user. Now, as it turns out, there actually is a web API that solves all of the problems that I've talked about up to now. Every single one. It actually works. It actually works in all the browsers, and it doesn't block the DOM at all. And that API is called Web Workers. This is my big reveal. I hope I hope the effect is worth it. And what Web Workers allow you to do is they allow you to essentially escape the single-threaded confines that you're usually stuck in when you're writing JavaScript. It's a way to tell the browser to take a bit of JavaScript and to run it on completely on a background thread. Does not touch the DOM at all, does not block the DOM for a single nanosecond. And it actually works. And it's super, super easy to use. Like, this is all the code in the world that you need to use a web worker. You don't need a library, you don't need a framework. They are super easy to work with. All you do is you have your code on the left, your main JavaScript file, and you say, hey, I want a new worker. And you pass in, path to worker.js. And then inside of your worker.js file, anything that you do inside of there does not block the DOM at all. And you communicate with this worker using asynchronous message passing. Now, that line about asynchronous message passing, that should set off alarm bells in your head if you've been listening to the rest of my talk. But as it turns out, the cost of this asynchronous message passing tends to be pretty small, especially if you make sure to send small messages to your worker, have it do a bit of work, and then come back with another small message. And I have some resources at the end of these slides talking about how you can optimize this even further. Can I use web workers? Yes, you absolutely can, and you should. They are very, very well supported. It's supported in IE 10 and above, and Android 4.4 and above. These things are very well established. And they really do work. Like, this actually solves all the problems I was talking about. You remember the example I did with IndexedDB where I easily block the DOM? Well, now that I'm doing it inside of a web worker, suddenly I'm incapable of blocking the DOM. Try as hard as I might, I cannot get this thing to block the DOM because it's all running inside of a web worker. It runs completely 100% on a background thread. Who's using web workers? A lot of sites. This is really just a partial list. A lot of sites like Khan Academy and the Monaco editor are using it for things like syntax highlighting and parsing. A lot of HTML5 games are using it because they really want to squeeze out the best possible performance to reach that 60 frames per second. But the point I want to make with this slide is that I really feel like when I see usage of web workers out in the wild, it's mostly that people think to themselves, oh, I have some long-running computation. Okay, now I'll use a web worker. Whereas I feel like most sites could benefit from web workers, especially if you're writing a site where you have 7 megabytes of JavaScript in your page. Like, there's got to be at least 1 megabyte of that you can put inside of a web worker. Like, please, there must be something in there that doesn't touch the DOM. And to illustrate this idea, I wrote this app, this open source app called Pokedex.org. And you can go try it out yourself. It's just Pokedex.org. And it kind of illustrates this idea that I had that a web application should mostly run inside of a web worker. And the idea behind this app is that every interaction on this page, like whether you're tapping, swiping, whatever you're doing, it actually just immediately fires off a message to a web worker, and then all of the interesting action happens inside of the worker. And I've been told that by people that they are amazed by the performance of this app, and I profiled it to see the performance, and it is doing most of its work on a background thread, which I think is part of the key to its success. So this is the architecture that I kind of dreamt up for this thing. It's sort of my idea of like what I imagined a framework of the future might look like. So it's kind of like you have this action that comes in the lower right. This is kind of Flux inspired. It's basically like Flux in a web worker sort of idea. So you have this action that comes in, it goes off into the web worker, and then it gets handled. It does all the IndexedDB operations, it does all the Ajax operations completely inside of a web worker, so none of that stuff blocks at all. And then I also do virtual DOM inside of a web worker, which is kind of interesting. So virtual DOM is this concept of like you generate a virtual tree and then you diff you diff that virtual tree with the old version of the tree, and then you have this patch, right? And then you apply that patch to the DOM. Well, it turns out that out of those 3 steps, the first 2 you can actually do without the DOM at all, which means you can do it inside of a worker. So that's exactly what I do in this app. I just do all the rendering and diffing, and that diffing can be very, very expensive. I just do that all inside of a worker. It's early days for this idea. Angular 2 is shipping an experimental web worker renderer. There's also been some experiments with React to run React's virtual DOM diffing inside of a web worker. This is not the kind of thing where I would tell you to go out and use it today. This is kind of bleeding edge stuff. But I think it's really interesting, and I hope that frameworks of the future start to adopt these ideas. Okay, so enough about web workers. Let's finally get to service workers. Okay, so I've explained, I hope adequately, the problems that web workers solve. So what problems do service workers solve? Well, it's a very simple problem. And that's this problem. Jake already kind of ruined the surprise on this slide, which is that there's a game in here. I love showing people that there's a game in here. Not a lot of people know. But on the bright side, I think I get a higher score than Jake did. So, yeah, I'm actually pretty good at this game. I've played it a bit. It's a fun game. This is a fun game, but this is not, this is not the experience that we're trying to give to our users, right, when they visit our website. Like, this is neat, but this is really not what we're trying to do when we're offline. So service workers solve this problem by giving you an API that is very, very similar to web workers and has a lot of the same concepts of running on a background thread, can't touch the DOM, all that stuff. But service workers have an additional superpower on top of web workers, which is that they can also intercept network requests from the main thread, essentially acting as a client-side proxy. So this is a very, very simple example of how you can use a service worker. As you can see, it's kind of similar to the web worker concept in that you have separate JavaScript files and you can communicate using asynchronous message passing, just like with web workers. But the important bit here is that I'm registering an event listener on fetch inside of the service worker. So anytime there is a network request at all from the main thread, I intercept that. I can go to the cache. I can go to the network. I can do whatever I want from inside of the service worker. So browser support for service workers, not so great compared to web workers. It's basically shipping right now in Chrome, Firefox, Opera. But if you go to Jake's lovely page, which is service worker ready, you will see that Edge is listed there as in development. So we are working on it right now. It is like the number one thing that we're working on. We kind of couldn't not work on service worker. Like we did this thing where we went out to web dev shops and we said, hey, what new features of the web platform are you excited about? And service worker came back in number 1 by a huge margin. Like, web developers really love service workers, so this is definitely a thing that we are doing because of that. So I'm not going to go into a super amount of detail about how service worker works because there's a lot of great resources. Jake's already covered a lot of this stuff. But I'll just let you know that if you want to get started with service workers, I would recommend this offline cookbook, which Jake made, which has lots of nice little diagrams showing, how you can do these really kind of subtle, tricky scenarios. Things like if you want to go to the cache first and then respond with the network later. If you want to fire off a request to the network and to the cache at the same time, and whichever one comes back first, you want to respond to that. He has lots of good examples for how to do that. So quick breakdown of the fundamental differences between web workers and service workers, because I think it's useful to understand these. In terms of tab control, with a web worker, you can actually have as many as you want in a tab. Like, you can just keep making workers, and they all run completely parallel to one another. Whereas with the service worker, the way it works right now is that you only have one for all tabs. So say you open up many, many tabs, they're all going to share the same service worker. Now, I put a star on this because this is actually being debated a little bit right now. There was a face-to-face meeting between Microsoft, Apple, Mozilla, Google, and as it turns out, Microsoft and Apple would kind of like to implement this in such a way that we can create many service workers per tabs for better performance. But currently, the current implementation in Chrome and Firefox is that you have one for all tabs. In terms of lifespan, the web worker lives as long as the tab that created it. So if you create a web worker inside of a tab and then you close that tab, the worker goes away. Whereas with a service worker, it can actually live outside of the tab. It has its own lifespan, completely independent of the tab, which is nice for certain things like push notifications and background sync, right? Because you want to be able to kind of wake up the worker or spawn the worker when you get a push notification or when a background sync event happens, even if the tab isn't open, even if the browser isn't open. Ideally, this is what you'd like to do. And then given their performance characteristics and the browsers that they're supported in, I would say that web workers are best for straight up parallelism. It's best when you want to achieve 60 frames per second, you want to move things to a background thread, whereas service workers are ideal for doing offline scenarios. I mean, you can imagine a future where service workers are better supported in all browsers, and maybe the kinds of things you do now in a web worker, you would just do in a service worker, but I think it's perfectly fine to use both web workers and service workers on a page. I mean, when you do, you're using multiple cores, you're using multiple threads. It's great. It's very good for performance. One thing I also found when I was building the Pokedex site, because it's a progressive web app and it uses service worker, is there was this really interesting, like really aesthetically pleasing kind of separation of concerns that I ended up with, where I noticed that I had this main JavaScript bundle file that was super tiny because all it was doing was just handling UI events, right? It was just basically making the UI look pretty, like adding little, splashes of animations, things like that. And then the bulk of the application logic lived inside of this worker, where it was parsed and executed completely on a background thread. And then the service worker also got its own JavaScript file, its own thread. And inside of there, I was just handling offline scenarios, handling network requests and responding with requests from the cache. All right, so I have a little bit of time left. So what I want to end this talk with is some pro tips, because when I advise people to start moving to use web workers and service workers, it can be kind of daunting at first because these are really alien APIs to a lot of web developers. And so I have some tips about how to make the best use of them. So the first thing that comes up that surprises a lot of web developers, kind of surprised me, is the APIs that are supported inside of web workers and service workers. Now, the most obvious missing API is going to be window and document, right? You can't access those inside of a web worker or a service worker. And that is a good thing. That is by design. You should not, because we don't want to be able to jank the main thread. We don't want to be able to block the DOM. So those things are just totally inaccessible inside of web workers and service workers. But some more subtle things may surprise you. So, for instance, there's no local storage in there. And that's actually also by design, because local storage is slow and synchronous and janky, and you should be moving to IndexedDB instead when you can. But also, local storage has race conditions. Like, what does it mean when you access local storage from inside a worker at the same time that you access it from inside the main thread? We don't know. That's a scary thought, so we just punted on this. So we don't support local storage inside of workers. Some other things may surprise you as well, is that you actually can't access XHR. You can't access XML HTTP requests inside of a service worker. You only have fetch. So this surprises a lot of people. A lot of libraries just won't work out of the box if they're relying on XML HTTP requests. And then just some other like subtle browser interop things that you'll run into. Things like Firefox didn't support file reader until recently. Safari didn't support IndexedDB. They're finally shipping it in Safari 10. So when Safari 10 comes out, it will support IndexedDB inside of a worker. And then even just things like console. This is really funny. Like if you are supporting Android 4.4, you may be surprised that you can't console log inside of a worker. So I found a lot of people running into these issues, and when they did, I would usually recommend them to this page, which is a great page maintained by Mozilla. This is MDN. It's a page called Functions and Classes Available to Web Workers. This is a really good resource. I've used it many times in the past. On the other hand, it has a downside, which is that this is manually curated, and it very quickly gets out of date as new browsers get released, and they might drop an API or add an API. So I wanted to provide a more automated solution to this problem. So a couple weeks ago, I wrote this thing, HTML5 worker test, which is another thing you can go and check out, just html5workertest.com. And the idea behind this is that it is a tool that runs in the cloud. It runs on Travis CI, and Sauce Labs. And it just tests browsers, and it queries their web workers and their service workers and asks exactly which APIs they support. So you can go to this tool, and you can be absolutely sure that this version of this browser supports exactly this API in a web worker or a service worker. So I'm hoping that this tool can be useful for web developers. I can show it to you right now. Let's do a live demo and hope it actually works. Oh, my resolution. Come on. I made this thing responsive, so let's hope it actually works. Conference Wi-Fi. Okay, you know what? I'm not going to wait for this thing to load. Just suffice it to say, it contains a matrix of all the browsers, various versions of those browsers. If you want to see older versions of the browsers, then you can just bring them up right here. Like you can see, hey, let's look up Safari. And you can see, for instance, when they added a certain API or when they dropped a certain API. Like WebSQL was dropped a few versions ago. Chrome did this as well. This was by design. But so the point of me making this resource, I I wasn't trying to like shame any one browser or another. You'll notice I didn't attach any kind of number to it or give a score. I think if I were to give a score, Firefox would probably win because Firefox has great WebWorker API support. The point of me making this thing was I just wanted to give a tool to web developers to better understand what's going on inside of a web worker and a service worker. Like these things can be very mysterious. You don't understand why your code is breaking. So I'm hoping this tool can help shed some light on what's going on inside these things. Yeah, so html5workertest.com. Go check it out. Some other things that may come in handy to you. As I said, you don't need a library or a framework to work with workers. They're very, very easy. But I find that when I work with them, I often write a lot of boilerplate code, especially dealing with message passing. So I wrote a little library to help out with that. It's called Promise Worker. And basically what this thing does, it's open source on NPM. The previous tool was open source as well. But this is open source on NPM. All it does is just allows you to post a message to a worker and then get a promise back. And then inside of the worker, you just define a function that returns a promise. So it's nice and asynchronous. I like working with promises, so it just makes it easier to communicate with workers that way. And you might use it, for instance, for something like querying to see if the web worker inside of a certain browser supports a certain API that you need or not. Because armed with the knowledge that certain browsers support certain APIs in web workers and service workers, you might reasonably want to feature detect, because that's the responsible thing to do, is feature detection, right? So in this case, what I'm doing is I'm just querying the worker and asking if it supports IndexedDB, and then when it comes back, that way I know whether I can run my application inside of this browser's implementation of web workers or not. And if it doesn't support some crucial API that you need to make your app work, then there's another tool I wrote, which is called pseudo worker. And pseudo worker is basically just a mostly spec-compliant implementation of web workers that runs entirely on the main thread. So that's my cue stuff. So you might use this in a case where there is some crucial API that you need for your app to work inside of a web worker, but inside of browsers that don't support that API, you just fall back to using a pseudo worker. And it runs on the main thread just like your normal non-web worker application would. But it's a good compromise. Okay, so I want to end this talk real quick with some kind of philosophical thoughts about this. So there's a reason that I personally get very, very excited about web workers and service workers. And the reason for that is that I actually did Android development for a long time. Like I did it for many years, even before I did web development. And when I thought about what I was doing as an Android developer to eke out every bit of performance, to squeeze out every bit of performance that I could from, very constrained mobile devices, and then I compared that to what I was doing when I wrote web applications, I found that it really came down to two things that I was doing differently in native apps, which was I was using parallelism, right? I was harnessing the multiple cores on those devices because they have slow CPUs, but they have multiple cores, so they can do multiple slow things at once, right? That's actually a really powerful thing. And then the other thing I was doing a lot was offline, right? I wasn't relying on the network because the network is unreliable. It can be slow. It can have Wi-Fi. And the local cache, even if you are online with a fast connection, the local cache is almost always going to be faster. So, and these two things, they now exist for the web. We have web workers to do parallelism, and we have service workers to do offline. So I hope you can get as excited about these ideas as I have, and I hope that you can start integrating them into your applications in order to give us beautiful, interactive, 60 frame per second applications that work well offline. That's my talk. Slides are online with links, lots and lots of research about all this stuff. So go and check it out if you get a chance. Thank you.